Okay, let's look at the homework number 7, problem number 8, right? So helium is pumped into a spherical balloon at the constant rate of 2 cubic feet per second. How fast is the radius increasing after 3 minutes, right? So let's try to answer that question first. All right, so since it's let's see, increasing at the constant rate of 2 cubic feet per second, so we can write the volume of the balloon as 2 times time in seconds, so 2t. And also we have a volume formula for a sphere. So I'm gonna write that down. It's a 4/3 pi r cubed, right? So I'm gonna set them equal to each other for now. So we're gonna get let's see, 4/3 pi r cubed is equal to 2t, right? Then I'm gonna divide both sides by 2 so that we can get rid of 2 here. So that becomes 2 here. All right, and I'm gonna isolate r cubed for now. So I'm gonna divide both sides, or I'm gonna multiply both sides by, right, reciprocal of 2/3. So it's gonna be 3/2. Right, also pi, right? So you can see that the 2 and 2 cancel out, 3 and 3 cancel out, pi on the bottom, pi on the cancel out, so you just get r cubed, right? So is equal to, right, so t times that, so it's going to be just simply 3t over 2 pi, right? So we got that. And then we can just take the cube root of both sides. All right, so I'm gonna just take the cube root of both sides. We get r is equal to, actually I'm gonna write it as a 1/3 power, so it's a little cleaner. All right, you have 3t over 2 pi to the 1/3 power. Alright, so we want to know the radius after 3 minutes. Okay, so this is in per second, so 3 minutes, I have to convert it into seconds. So 3 minutes is 180 seconds. Alright, so when t equals, right, 180, right, so we know that the r is going to be, radius after 3 minutes is going to be, r is equal to, all right, so we plug in, so we have a 3 here, and times, so t is 180, so 180, right, over 2 pi, and raise it to the 1/3 power. Right, so I'm gonna cancel, let's see, 2 and 180, so we're gonna get 90 here. Right, so you get 3 times 90 would be 270 over, there's pi there, so you have pi, right, raise it to the 1/3 power. Alright, so that's the radius. Alright, so let's take the derivative, implicit differentiation, then plug in all we know. Alright, so take the derivative of volume with respect to t. So we're going to take the derivative with respect to t from here. So we know that it's going to be dv over dt, right? So this is equal to, right, so you have 4/3 pi, just a constant, so put that in front, so 4/3 pi, right, So derivative of r cubed is going to be 3 in front, r, subtract 1 from the power, so it's 2, then multiply by dr over dt, right? Then clean that up a little bit, so you have 3 here, and the 3 on the bottom cancel out, so you get 4 pi r squared dr over dt. Alright, so since we're looking for, let's say, how fast is the radius is increasing, so we're actually looking for this guy. So we're looking for this guy. Alright, so I'm gonna just I'm gonna actually go ahead and solve for this guy, and so we know that we can just divide dv over dt by this guy. So this will give us, so I'm gonna go down here. Alright, so by dividing through by 4 pi r squared, we can get dr over dt. That's what we're looking for. It's all by itself, so you just have to divide dv over dt by 4 pi r squared. Right, then let's plug in everything we know. Alright, so dv over dt, since it's increasing at the rate of 2 cubic feet per second, so that will be 2 on top, and then you have 4 pi, so 4 pi. Alright, then r squared, r, we just found out that this is the guy, so I'm gonna just try to type it in. Alright, so this guy is square, so r is quantity. Alright, 270 over pi to the 1/3 power, but we have to square that, so it's going to be 2/3 power. Alright, so we're going to clean up so that we can compute this number. So you have a 2 and a 4 cancel out, so you have 2 left over here. Alright, I don't like having this fraction here, so I'm gonna just write it as, let's see, so dividing by 270 over pi raised to the 2/3 power is same thing as multiplying by, just reciprocal, so I'm gonna just do a pi over 270 and raise it to the, so notice that I took the reciprocal, so 2/3 power. Right, then you just need to divide by, right, 2 pi. Alright, so let's get this value here. Alright, so pulling out the calculator. Alright, so we need to do, let's see, I'm gonna do this one first. So you have pi, alright, pi divided by 270, right, and raise it to the 2/3 power. Alright, and then you have to divide it by, alright, 2 pi. Alright, so let's compute that number. Alright, so it came out to be 0.00817. So let's see, what's the alright, so we want to round to 4 decimal places. Alright, so let's type it in. So it's going to be 0.008 so 17, so it's going to be 82. Alright, so let's check the answer. Alright, so we got that. Alright, so the next question is that, let's see, time at which the radius increases at the rate of 100 feet per second. Alright, so let's look at that. Alright, so oh, actually, maybe for that, the answer I had was 0.0082. Right, so that was that. Alright, so for the second part, we already know that the radius is increasing at the rate of 100 feet per second. So we already know dr over dt is equal to 100. Right, so we have that. Okay, so plug this guy into the equation here. So dv over dt, we already know that it's 2. So this is going to give you, let's say 2 is equal to, all right, so look at here. So you have 4 pi, right? Here you have a r square. So we found that the r is actually, so right here. Here's the expression for r. So I'm going to put that in. So it's going to be 3t over 2 pi raise it to the 1/3 power, but we have to put the r square, so it's going to be a 2/3 power, right? Then dr over dt is given to be 100, so times 100 here, right? So here's an equation we need to satisfy. The only unknown is t, so we just have to solve for t there, right? So let's do that. So first we're gonna divide through by, right, we want to isolate t here. So I'm gonna divide through by 4 pi and a 100 here. So let's do that. So this is going to be, all right, so 2 over, all right, so you have a 400 pi. All right, so we took care of 4 pi, and also we took care of 100 here. All right, then we can probably cancel 2, and this is going to be 200 there. 200 pi and 1 on top. All right, then so this is equal to, right, so you have 3 over t, 3t over 2 pi raise it to the 2/3 power, right? Then next step would be, since we have 2/3 right here, we want to get rid of that. So I'm gonna just go ahead and multiply, raise it to the 3/2 power. So raise it to the 3/2 power. So what you get is you have a 1 over 200 pi raise it to the 3/2 power, right? And this is equal to 3t over 2 pi, right? Then last step is we want to isolate this guy, so we can just simply, I'm gonna go down here, all right, multiply both sides by 2 pi over 3, right? So that way you will get t is isolated, right? So I multiply this guy by 2 pi over 3, so t is isolated, and I'm gonna put this guy over to the other side. So you have a 2 pi over 3 times 1 over 200 pi raise it to the 3/2 power, right? So let's compute that. Right, so I'm gonna do about 2 pi first. So you have a 2 pi, right? Then we just need to divide by 3, so it's gonna be divide by, right, 3 times, right? So we need to have a 200 pi too. So you have a 200 pi, and we have to raise that to the 3/2 power. So 3 divided by 2 power. Alright, then close parenthesis would probably do it. So hit enter. Alright, so it came out to be 1.32987 and times 10 to the negative 4. Alright, so this is going to be, let's see, what's the precision? Go over here. Alright, so we want to write it, let's say, round to the 5 decimal place. Okay, so this is going to be equivalent to, right, so 0.000, so I need 4 zeros because 10 to the negative 4 power. Right, so you have a 1, 3, so it's going to be just a 1 and 3. Right, so you have 1, 2, 3, 4, 5 decimal places. Right, so let's check the answer. Alright, that's that. Alright, that's it. I hope that this was clear.